Okay, today we are going to look at another video. So the question says, show that sum n from 1 to infinity of r to power n cos nx is equal to r cos x minus r squared all over 1 minus 2r cos x plus r squared. Now I saw this question and then I found it interesting and said let me do justice to it here. Now recall that exponential I(nx) is equal to cos nx plus I sin nx, De Moivre's theorem. So if you're having any problem with this, just recall your De Moivre's theorem. So it's not in the De Moivre's theorem. Okay. Now also exponential minus I(nx) is equal to cos nx minus I sin nx. We have this minus here because of the one that is at the power of the exponential in the second equation here, the left hand side. So if we substitute into this place minus I, the minus will come out here immediately. That is how it happens. So sine is an odd function. That is why it is like that, unlike cos. Cosine, which is an even function, it swallows whatever sign it takes, so and bring it out positive. Okay, let's look at the second part. So now if we go back to what we have here, so now if we decide to add both sides, if we add this side and add this side, so the sign that has the side that the terms that have sign will go. For instance, in the first equation we have plus I sin nx and minus I sin nx. So this minus and plus will go because the opposite signs will go. So we'll only be left with 2 cos nx at this side. So then, and that is what gives us what we have in the upper part here, that cos nx is equal to half of exponential I(nx) plus exponential minus I(nx). So now if you multiply through by r to power n, we will have this. Just distribute the minus to both sides. Distribute r to power half of r to power n to the 2 times at the left hand side by opening up the bracket. So we will have this. So now this will be equal to half r exponential ix to power n plus half r exponential minus ix to power n, because a raised to power nm can actually be written as a raised to power m or multiply or to power n. So this was why I was able to do this, and I'm free to do this. It is in indices. So now we see the next thing. Now if we try to sum both sides, we will have this. For instance, sum of ai, sum over I of a, sum of ai plus bi. I can write it as sum of ai then plus sum of bi. Sum is linear, that's why I'm doing this. So, and since half is independent of n, so I am free to bring it out as just a constant term, as a constant multiple of r exponential ix to power n, because it is independent of n, so I can bring it out in both terms. So now if we look at it, this is a geometric series. If we take sum to infinity of this geometric series, if n is 1, what is the first term? Excluding half, what is the first term? The first term is r exponential ix. And the common ratio is also r exponential ix. Then if we have a geometric series, let's say we have sum r to power n from 1 to infinity or some a over b all raised to power n. So let's say the first term we know, okay, let me not use this one. If we have a plus a squared plus a cube plus, this is a geometric series. What then is our common ratio? Our common ratio is 1, is a. Our first term is a, and our common ratio is just a squared all over a, which is equal to a. So our common ratio is a. So from that place, our first term is r exponential ix, and the common ratio is also r exponential ix in the first term. So then the sum to infinity of that series is r exponential ix all over 1 minus r exponential ix. The same thing happens to the second term. So the same thing is what I applied in this second term. Then if you go to the last line here, what I did is just to bring out r. I just brought out r is here, half is here, half is here. So I can bring out r over 2 from both sides because it's common to the two terms. So I can bring it out. So, and I'm now going to simplify what I have inside this big bracket. So when I do that, I will then have this. Just simplification is what give me this. And now where I need to talk about is how I got the last line, how I got r here now. Remember that exponential ix times 1 is exponential ix, and exponential ix times r exponential ix is r. Reason being that exponential ix, remember that 8 raised to power n times a raised to power m is equal to a raised to power n plus m. So that was how I got exponential ix minus r exponential times r exponential minus ix as what? Only r. Reason being that exponential ix times exponential minus ix is equal to exponential ix plus minus ix, which is exponential ix minus ix, and that is exponential 0, which is equal to 1. So 1 times r is r, and that's why this is it. Similarly, the same thing happens here. So if you do the same here now, if you do the same at this point, you will still get the same thing here. So for the denominator, if you expand the denominator by applying the same techniques, you will get what I got here. Here now, there's this demarcation. Okay, then we go for the next. Then here finally we already have r all over 2 and this. Then we recall that exponential ix plus exponential minus ix is equal to 2 cos x. So that's why I replaced exponential ix plus exponential minus ix as 2 cos x. So I replace it with 2 cos x minus 2r, which is what we have there by collecting the like times. And then in the denominator, I also have the same thing here, 1 minus 2r cos x. So finally, we have r cos x because 2 is common to both sides, we can bring it out in order to remove the half that's outside. So that 2 that is multiplying the numerator can take care of the half. So and then pushing the r outside to remove the bracket, and we get what we are trying to show. So which is the final thing we have as at the last line. Thank you for watching. Endeavor to subscribe after watching this video. I will still be uploading videos on real analysis, but as I've changed my mind now, it won't only be videos on real analysis. I will still be adding videos, random videos in mathematics, everything in mathematics. If I come across any question that is not straightforward, I will always ensure I drop the video. So you can use the same thing to show that sum n from 1 to infinity of r from 1 to r raised to power n sine nx over 1 sine nx, yes, is equal to, I think that is r cos x. I think what will change is that this r squared will go. You will have r cos x. No, you will have r sine x all over 1 minus 2r cos x. This r squared will go in that case when you change cos to sine. Thank you.